friends, welcome back to the channel. It's Given from Techno Drive. Today we still have that Kodak inverter. This is the inverter that I used to demonstrate the difference between high frequency and low frequency inverters. It's the same inverter. So this one is OG5.48. You can see the 5.48. So this is the 5000 watts inverter. It has got an alarm. So the alarm is F09. Let's connect it, then you can see. Okay, before we can fix it, I just want to show you something. Some of the customers, they asked why sometimes when you connect the battery, you've got a spark there. Let me show you the spark that comes in when you connect. But I think it's interesting to know why are we having that spark. I'm going to explain a little bit more in detail today. Just take a look at the battery there. You saw a spark there. It sparked once, and then there's nothing. Now it's no longer sparking. Switch on the inverter. See, we are having F09. So that's the alarm we're having, F09. So that alarm we are going to sort out today. But before we can fix it, I just want to explain more why are we having that spark. So the spark there. Okay, that spark is caused by the capacitors. I've got one capacitor out from another board. You see, capacitors are very important components in inverters. There's lots and lots of different capacitors in inverters. You can see some of the types of capacitors that you might find, but it's not all that you can find on the inverters. The common one on inverters is electrolytic. This one is the one that's been used commonly. You do get the ceramic, the polyester, and the mica, but the most common one is this electrolytic. Okay, so let me explain why we have a short or a spark when we start connecting the battery. I'm sure when you work with inverters, you came across something like this. It's good to know why are we having that. Okay, you see, on your battery terminal, the battery goes to these capacitors. The plus and minus goes to these 2 points. So that's why you're having that spark. Why you're having the spark is because when the capacitor is discharged, it acts like a resistor. So, for instance, if I short the leads here, don't do it on your battery. I've got a protection on my power supply. I can short it and there won't be any problem. I just want to demonstrate. So if I short here, you see I've got a spark. So it's basically I've got a 0 ohm resistance between the positive and negative. So that's why I'm getting that spark. So that voltage has no way to go. So it creates a spark. So now on the capacitor, I've got a very same scenario. Let me connect the positive and negative. You will see. You must remember the capacitor has got the polarity. This side is negative and the other side is positive. Do not swap them when you're working with electrolytic capacitor, otherwise they will burn immediately. Okay, let's charge it. You saw the spark there. That's what you get when you connect the inverter for the first time. So if I connect again, you see there's no more spark. You see now it's charged. That's the reason why when you connect the battery on the inverter terminals, you get a little bit of a spark. It's because the capacitor is discharged and the resistance is low, and then it needs to be charged to a working voltage. Okay, So the other thing that you have to know on capacitors is that these are very dangerous. You can shock yourself out from these capacitors. Why? It's because even if they are they are disconnected from the board, or the battery is not connected, you still have the voltage inside the inverter. So that voltage is dangerous. It can shock you. Imagine if we are working with high voltage capacitors, because here is a 63 volts. This is a low voltage capacitor, but on the inverter you've got capacitors rated at around 450 volts. So those capacitors, they are large. So if you touch while they are still charged, you've got the risk of shocking yourself, and it won't be nice. So it's good to explain that. So let me demonstrate to you. You will see I've disconnected the charger there, but we still have the voltage. You see, if I connect the positive and negative, see what happens. You saw there. It's not nice, eh? You saw there. That is because the capacitor is now charged. So if it's charged like that, you still have a voltage there. So it's very important to discharge the capacitors, because if you work on the board while the capacitors are charged, you've got the risk of damaging electronics. Let's say, for instance, you are working on this board. The capacitors are charged and you've got voltage coming in here. So if you've got that voltage, you do something and you short the pins there. So the voltage that is inside the board can jump from there to the other side, and you find that on the chip, let's say maybe it's a output pin, and you connect the voltage on the output pin of the IC. Obviously that IC is not programmed to get a voltage there. You're gonna damage the chip. So it's better to always discharge the capacitors, and also for your safety, it's not nice to be shocked by inverters. So I thought it was good to explain why are we having that short, and the dangers of capacitors. Let's be safe. Let's play safe with inverters. We are working with high voltage here, so it's better to know and understand. And also, this inverter, it has got a damaged capacitor there. So when this capacitor gets damaged, it doesn't fail alone. That's why we're having that F09. So we have to also change all those capacitors. You can see this one, it's like bulged. So we are going to change it, and also change the components around the circuit to make sure that the inverter is okay. So let's fix the inverter. I've already showed you, it's showing F09. Let's Okay, I've got the board out. Let's check why we are having that F09. Okay, I've got the multimeter here. What I know is that we have a short on the DC bus, high voltage DC bus. That's why we are having that F09. I will check and see which components have failed. But let me show you. So I've just explained about the capacitors. Just make sure that you don't have the voltage on the large capacitors and also the low voltage one. You can see we've got 23 volts there, so it's better to discharge it. Let's discharge that 24 volts. Okay, I've got the resistor. We can use the resistor to discharge. Yeah, no longer have a voltage now. You can see nothing. Okay, let's check the. So this one is a large capacitor. Let's check the rating there. You can see this capacitor is rated at what voltage? It's 500 volts. This is a high voltage capacitor. This one, 500 volts. So what I've just explained about the capacitor is that if you have a high voltage, like maybe 500 volts, on these 2 points here, because this capacitor, you've got these 2 points here. These are the points for the capacitor. This 1, 2. So if you have a 500 volts here and you touch it by mistake, obviously it's not gonna be a good experience. So we are having a short circuit there. That's why we are having F09. So that's the first thing that we have to check. If we have a short circuit on the big capacitor, obviously we're gonna have a F09 because the inverter is trying to charge the capacitor, but the capacitor is dead short circuit, it's not charging. Then it will just throw that alarm F09. Let's check the transistors. See this one. This one is gone. It's gone. One looks okay. One looks okay. One looks okay. 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 So on my side, normally once I have F09, I change all of these IGBTs. It's basically 1, 2, 3, 4. This is your inverter IGBTs. So once I have a short on one IGBTs, because the other ones, they are also on the same circuit. So let's also check the MPPT IGBTs. So these ones, they look alright. So these ones I will leave them, but these 4 I will change and also check the optocouplers. Let's do that. We have to remove this. Okay, we are now done replacing the IGBTs. We are going to change one cap that was not okay here. This one. So 470, 25 volts. You can see it's no longer flat, so we have to change that. Okay, I've changed the cap. There is the replacement cap. Let's test it. There we go, we've got 230 output. So the inverter is now okay. You can see there we have a voltage now, we've got 230. There's no more F09. So it's time to close it, and we're done with the repairs. Thank you very much.